Hi, my name is Nick Borson, and in this video I'm going to talk about Git, the version control system. And specifically, I'm going to talk about how to use Git to work on an open source project that's hosted on GitHub. Now, if none of that makes any sense to you and you don't know what Git is, I would suggest going back and watching my earlier Git 101 video. I will include a link to that in the description. In that Git 101 video, I just explained some of the basics of Git and showed how to create a local Git repository on your own computer. And that is somewhat useful because it's nice to have Git being able to retain version information, the history of all your files in a project. But where Git really comes into its own is the ability for multiple people all to work together on the same project. Because having a version control system means that we can all work on the same files without having to worry about stepping on each other or overwriting each other's information. It's much better than just like passing files around through email or copying them to a file share, because in those cases, your changes might overwrite my changes might overwrite your changes. A version control system allows those changes to be, each of us to make changes and our changes to be merged in a controlled way into the shared repository. Now with Git, the way that and with GitHub, or in any kind of thing that's based on Git, the starting point for working on a shared repository is to create a local clone of that repository. So there's a repository on GitHub, and then when I clone it, I have my own copy of that repository on my computer. And I assumed that the sheep in this stock image is a reference to Dolly, the first cloned sheep. So the first step in working with Git on GitHub is to clone the repo. And after that, we make changes by going through this typical workflow, which is to create a topic branch in our own clone. I'll explain what that means. Commit changes to that branch. Ultimately, we push that up to the shared repo, create a pull request, and when that request is approved, we can merge our changes into the main branch on the shared repo. Now, I just went through a lot of terminology there about branches and merging and pushing and pulling. Before going into all that, let me just talk a little bit more about cloning. So Git uses a distributed design, which is different than some other version control systems that use a client-server design. In a client-server design, you would have the version control system has the whole project hosted on a server somewhere, and then you would have, what you have on your computer would just be kind of a local view of that project. But what you have on the client on your computer is fundamentally different than what's on the server. With Git, it's actually a distributed design in the sense that there's a full repository on the server and a full repository on your client computer, and they're really kind of equal to each other. Neither one is dependent on the other. However, they can talk to each other. You can exchange information between repos. And if you think about it, that's necessary. There has to be a way to do that. Because otherwise, after you clone the repo, you would just kind of go your own way and never be able to exchange information with other people. Ultimately, what you want is you want to be able to make your changes and get them up into the shared repo. And of course, if other people are making changes, you want to be able to get them, you want to get yourself updated to reflect those changes. So this is done by having the ability to push changes from your repo to a remote repo, and pull changes from the remote repo down to your repo. And Git has this concept of remotes. You can have any number of remote repos, but by convention, there is a special remote called Origin, which is the default remote repo. And when you clone the repo on GitHub, your local clone's origin is an alias for the URL of the repo on GitHub. So when you do the push and pull commands, you're pushing up to the origin repository, and when you pull, you're pulling down from the origin repository. Okay, enough with the theory. Let's take a look at an actual GitHub repo. So here I've navigated to github.com and navigated to a particular project, which happens to be an open source project that I created. This project is called AdventureScript. It is a scripting language, an interpreter, and game engine for creating text adventure games. So The details of this project are I won't go into a whole lot here. I think I'll probably create some other videos about it. But for now, I'm mostly interested just in showing you how you can clone this, and this is an example of a GitHub project that you could clone and do your own work on. So like most GitHub projects, there are certain conventions that are followed. Projects generally have a README file, which just describes what it is. These are, you can see the .md extension. That's because this is a Markdown file. MD is for Markdown. Markdown is a very simple text-based format for creating, for creating files. But the source is, if you look at the text, it's quite, there's like the £sign here means it's a heading. The hyphens are for bulleted lists and things like that. So it's quite readable even as raw text. But a Markdown engine can give you a nice formatted view of it, including things like links and stuff. Anyway, so pardon me. So projects typically have a README file. They typically have a license file that tells you how the code is licensed. This is an MIT license that allows for you to do pretty much whatever you want with it. And it's common for projects to have a contributing file, which tells you guidelines for what sorts of contributions, if people want to participate in a project and add things to the project, what sort of contributions are welcome, and what the kind of ground rules are. But so that's just stuff you'll typically see on a GitHub project, on an open source project. But how do we actually code? How do we actually begin working on the project? Well, the first step is to clone it, like I said. So on GitHub, you go to this green button that says Code, and here we have the word clone, and there's here's the URL of the project, and next to it is there a little button to copy the URL to the clipboard. So we click on that, and now we've copied the URL to the clipboard. Then if we switch to a PowerShell prompt, here I'm in my repos directory, and if I say git clone, and I'll just paste that URL, then it says cloning into AdventureScript, so it creates a subdirectory with the same name as that project. And now if we cd into that subdirectory, here we have all those files. We have the README, we have all the other Markdown files, and all the source code, and so on. We also can say git status, for example, and it tells us that, yes, this is indeed a Git repo. We're on branch main, and so on. So we've created our local clone, and we can begin coding. So let's say that I want to make a change to this project. This is where the Git workflow I alluded to earlier comes into play. Now, in my Git 101 video, I made some changes to my local repository, and I just committed changes directly to the main branch. But that's generally not going to fly when you're working on a shared project. People want a little bit more control over what gets merged into main. So instead, the process that people follow is you start by creating what's called a topic branch. That's just the term we use for it. It's just whatever branch, you can give it whatever name you want, but you create a branch off of main, and then you can make as many commits as you want to that branch. A commit just being a change that you're committing to that branch. And these have no effect on the main branch. It's like a parallel timeline. Your topic branch is like a parallel timeline to the main branch. Then, when you feel like you've got a sort of a set of work that you think is in good shape and ready to be merged back into main, then you push your topic branch up to the remote repository, and you create what's called a pull request. A pull request is an opportunity for other people to see. It's essentially a way of saying, hey, I have some changes in this branch and I want to merge them into main, and it gives other people a chance to look at and review those changes. And they can suggest feedback. This is what's called code review. They can review your changes, suggest feedback, and then if they're satisfied with your changes, they can approve your pull request. But if there are, if you need to address that feedback, all you do is you commit additional changes to your topic branch and push them up to the remote, and then your pull request is updated with those latest updates. But once everything is satisfied, people are happy with your change, they can approve your pull request, and then you can complete the pull request. At that point, your pull request, the changes from your topic branch get merged into main. We say merged because there could also be changes in main. So in this diagram, for example, the little circles are representing commits. So we have, you create your topic branch off of main, and then you make 5 commits here on your topic branch. But meanwhile, a couple of commits have been made on main. So your topic branch is now behind main by 2 commits, but ahead of main by 5 commits. There's 5 commits of yours have to be merged with the 2 commits of other people in order for the branches to be merged back together. But Git can do that merging automatically in almost all cases, unless you've literally edited like the same line of code as somebody else, in which case some manual merging is required. But that's usually fairly rare. Go ahead and make a change. So here in the root directory of my AdventureScript repo, there is a Visual Studio solution file, adventurescript.sln. So just by typing that, I can open that in Visual Studio. So here it is already opened. And we see that we have a solution with 4 projects. There's the AdventureScript project, which is a shared library, a DLL on Windows that implements the AdventureScript language and interpreter for the game. Then there's a test, and there's a WinUI app that can run the game in a kind of a GUI. And then there's also a console-based terminal app that's used. One thing that's missing from the solution file is the README file is not actually added to the solution. Not that it needs to be exactly, but just it's nice to have it there for editing purposes. It doesn't actually get built. It doesn't get compiled or anything like that. But it occurs to me that might be nice. So let's go ahead and add that. That can be part of my change. So I'm going to go back to the PowerShell prompt, and I'll start by typing git status, and we see that we're on the main branch. And just to make sure, before I start making my change, I'm going to make sure that my main branch is up to date with what is on the origin, on the remote. So I'll say git pull. So that way I'm synced up with whatever is up in the cloud, pulled any changes that are up there that might have been made, so that I'm starting from kind of the current state of things. Turns out I'm already up to date. So then I can create a new branch, and I can create the branch and check it out at the same time by using this command, git checkout -b. So that means we're checking out a new branch. And by convention, I'm going to call my topic branch, I'm going to use my name as part of the branch just to avoid name collisions with other people. So I'll say user Nicholas Borson, and I'm going to call this README because I'm going to make some changes to the README file, or things really. It doesn't really matter what I call my branch. The branch name is just for my own information. But it is helpful to include your name in the branch, like your GitHub login name or something, so that your branch is not going to be confused with other people's branches, or you won't have name conflicts. Anyway, so now I've switched to a new branch called README. And if I say git status, we see that now I'm on branch user Nicholas Borson /README. So let's go ahead and make some changes. I'll go ahead and I'll edit my solution file by just saying, I'm right-clicking on the name of the solution. I'm going to say add existing item. And I can browse the project, and I can say I want to add all these markdown files. I want to include them in my solution. Okay, and they just show up in the solution items folder. And they don't get built. If I right-click on this and choose properties, there's no build action associated with these. They don't get compiled. They're not part of any project. But just having them in the solution file means that they're there visible if you're from Visual Studio, so you can edit them from there and so on. So here we have the README file. And now if I save this, or save everything, save the solution, then if I go to my Git Changes tab in Visual Studio, we can see that the SLN file has been updated. And if I double click on that, we can even see what changes Visual Studio has made. My project has been edited to add these solution items. So there's a solution items folder, which includes these files. So that's the change I just made. So let's go ahead and commit that. Now I can do that from the command line, or I can do it from Visual Studio. I'll do it from the command line this time. So again, if I say git status, It tells me that this SLN file is modified. So I can say git add -- all will add all changes so that they're not staged, ready to commit. If I can say git status again, we see that that is now a change to be committed. So previously it said changes not staged for commit. Now it says changes to be committed. So if I say git commit, and I can type in the message all at one time, so I'm not prompted for it later, I'll say add markdown files to solution. Okay. And now there's nothing to commit. The working tree is clean. My branch is now ahead of the remote branch by 1 commit. So I can go ahead and push my branch now, even if I don't intend to merge it until later. And all I do is I say git push. Now the first time I do this, it's going to prompt me to set the upstream branch for my branch. I'll explain what that means in a second. So it's complaining the current branch has no upstream branch. Well, what does that mean? It means that when we push, we're always pushing to a remote. And you have to specify what branch is what is the branch that you're pushing to. And we can do that by saying, by just copying. I'm just going to copy and paste what it suggests us specifying, which is when we do the push, we're setting the upstream branch, and the upstream branch is just going to be origin user Nicholas B readme. In other words, within my repo, there is my own local readme branch, but we can also have an origin readme branch, which is kind of my own local view of what that branch is on the other repo, on the origin repo. So we're pushing that. Actually, we're pushing it literally to the remote repo. Okay, and now if I go up to GitHub, we can see that, yeah, here we have this branch now exists. 3 seconds ago, we had a push. And if we wanted to, we could create a pull request right now. But let's go ahead and make another change first. Let's say we actually want to edit my README file. So go back to Visual Studio. And in addition to the shortcomings that I saw earlier, I noticed that the README lists the different directories in the project, but it does not mention, if we do an ls here, we see that we have an AdventureScript directory. Well, we've got that. We have an engine test directory, a docs directory. We've discussed those here. We have a games directory, a text adventure directory. Those are both covered. But there's also this Oxbow Castle directory, and I did not mention that in the README. So let's go ahead and do that. I'll put it next to the text adventure one because it's sort of similar. So in Markdown, we use the hyphen to indicate a bulleted list. Oxbow Castle is a WinUI 3 application implemented using the AdventureScript library. Okay. So I'm going to save that, and now we have another change that's ready to commit. So when there get changes, now we show that README has been changed. So I'll go ahead and make a note of that. This time I'll commit it from within the Visual Studio user interface. I'll just say add Oxbow Castle directory to README.md. Commit all, and we can. If I wanted to, I can stage this, but I can also just commit and stage it in one step from within this user interface. And then if I want to push this to the cloud, to the server, to the remote rather, I can actually just use this little push button here. The little up arrow means push. So we can also do the push directly within the Visual Studio user interface. Okay, so it's initiating the push. Gives me the status message that it completed. And now if I go back to the website, then if we say compare and pull request, this is so look, there are a couple ways. First of all, if we've pushed recently, GitHub generally will prompt us and say that there's a change 20 seconds ago. Do you want to compare and pull request? The other way you can do it, we can go to we can look at our branches, and we see that we have 6 branches in this repo. And this one right here is the one that we just are working on. If I go to the dot, 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 I can say new pull request. Okay, so that's another way we can create a pull request, either by clicking that button, or if we don't see something like that, we can do it here. So pull request should have a title. The title will ultimately, when you merge the pull request, the title will end up being, if you merge it with what's called a squash commit, or a squash merge, I mean. I'll explain that in a second. When you merge a pull request, this title will end up being the name of the commit. So you should use a descriptive name. So I'm going to say update readme.md and add to solution. Okay, and I can give a more detailed description if I want in here. I could say add Oxbow Castle directory to readme.md, add readme.md and other markdown files to Visual Studio solution. Okay, once I'm satisfied with my description, and the description kind of should have enough information that anybody reviewing this can, anything that's not obvious from just looking at the change itself, the description might give them some guidance of what you're trying to do. I say create pull request. Now the pull request exists, it's available, other people can see this pull request if they go to the project. And from the pull request, we can see, first of all, there's a conversation tab that shows what other people have said about it, so that people can comment on it here. There is a commits tab that shows all the commits to this pull request. We can see we have these 2 commits. And then there's a checks would be if the project had, it's possible on GitHub to create what are called GitHub actions, which is code that automatically runs on the server, runs in the cloud to do things like running tests and things like that. I haven't set anything up like that for this project. And then finally, there's a tab that shows what the actual changes are. So we have changes to the solution file, and we have changes to the README file. And so a reviewer can go through and actually make comments online. I can actually select this and say, I can select this and say, add a comment like, could be more specific or something, whatever. I'm going to cancel. I'm not going to make any comments. Once somebody has reviewed the change, they can approve the change, and different projects might have different policies for what is required for a change to be ready to merge. Maybe it has to pass some tests or something. Maybe it has to have multiple reviewers. In this project, you just have to have one reviewer. So right now, merging is blocked because there aren't any reviewers. Now, I happen to be the creator of this project, so I've allowed myself to bypass this check, since so far I'm the only one working on this project. It would be kind of awkward if I couldn't make any changes to it. So I'm allowing myself to bypass that check, but generally speaking, you have to get somebody to review something. Now, reviewing the code review process, by the way, is extremely useful. Not just, it's useful for the project in order to keep quality up, to provide, some gatekeeping there and getting another pair of eyes on stuff. It's also useful to you if you're submitting a change, to get those extra eyes, both just to have other eyes to, in case you made a mistake, have other people be able to help you catch those mistakes. Sometimes a fresh pair of eyes is useful. But it's also an extremely important learning tool, because there might be other people who are on the project that know more about that project, or are just more experienced developers than you are, and you can learn from them. They can give you feedback that helps you understand things you might not have known about that project, or maybe just help you guide you to a better way of solving things. So code reviewing is a great way of spreading knowledge within a team or within a group of collaborators. And as long as you look at it that way, as not as a way of being critical, but as a way of respectfully passing on knowledge and helping everybody to up their game and improve their quality, it's a super useful tool. But as I said, I'm kind of bypassing it here because it's the only way I can get changes in until other people start collaborating with me on this project. So now at this point, I'm going to merge the change, and by default, I'm doing for this project, I'm doing a squash merge. There are two ways of merging a PR. You can do um, a rebase and merge or a squash merge. So rebase and merge would preserve each individual commit in the history of main. Squash merge takes all the commits in my branch and combines them into one, squashes them into one, and so we end up just with one commit at the end. So all my little intermediate commits will not be preserved, and that's what I want for me. I mean, it can be a matter of preference. So I'm bypassing the usual rules. So once I've merged my pull request, my topic branch is no longer really needed. So I can say delete branch. And now my topic branch is gone on the server. And if we go back to the repo now, and we look at, now we're back in main. And now if we look at the AdventureScript README, we see that in fact it does include my new bullet point for Oxbow Castle. And if I go back to my command prompt, at this point on my command prompt, it doesn't reflect any of the changes in the pull request. If I say get status, I'm still in my old branch. So that even though I deleted that branch from the repo on GitHub, it still exists in my local clone. So now just to kind of get back onto main, I'm going to check out main again. Check out main, get check out main. So now I'm switched back to the main branch. And now it thinks my branch is up to date with origin main because I haven't pulled the changes down from the remote repo yet. So I can do what's called a git pull, which will pull the changes down from main and also merge them into my main branch. But I can also do it in two steps. And just for illustration purposes, I'm going to do it in two steps. So first I say git fetch. Git fetch doesn't actually, git, not get, git fetch. So fetch does not actually update my main branch, but it does pull it does download the information from the remote repo. Okay, so it's fetching. And now if I say get status, now it knows that your branch is behind origin main by one commit. So in other words, there's been another commit to origin main that is not reflected in my main branch. Now if I say git pull, then my main is up to date. Okay, so now my SLN file, you can see that my SLN file was updated and my README file was updated. So it updated both of those because that was what that commit did. And there's finally one more thing I can do. I no longer need my old topic branch. So, or if I say get branch rather, it will list all of my branches. So I'm going to just select the old branch name that I no longer need and say get branch -d to delete that branch. And now I'm just have main again. Okay. So that was kind of the whole life cycle of a change. We started by creating a topic branch on my local repo. I committed changes to that topic branch. I pushed those changes up to GitHub. Then I created a pull request on GitHub. Then I completed that pull request, which merged the changes back into main. I deleted the branch on GitHub, the topic branch on GitHub. And finally, back on my local clone, I switched back to main. I checked out the main branch to switch back to the main branch. I did the fetch just for illustration purposes. I could have just said git pull and that would have done the whole thing. I updated the main branch to reflect what's on GitHub. And then finally I deleted my topic branch, which was no longer needed. So that's kind of the whole life cycle of a change. Well, not quite the end. I do have one last little slide just to do a review of what we covered earlier about the Git workflow. So again, when we want to make a change, we start by creating a topic branch, and we can use the git checkout -b branch name to do that. We commit changes to the branch using git add, editing the files in your local working tree and then using the git add and git commit, or you can use the Visual Studio user interface, or there are various other GUI tools for working with Git. When you're done, you can push your change to the remote, and then you go to GitHub to create a pull request, address any code review feedback. You can push, you can make additional commits and push those to your topic branch. And finally, you merge your pull request, And when you're done, you can delete your topic branch both on GitHub and on your local repo. So that is working with Git, working with a shared project. I hope that that is useful, regardless of what project you work on. And also, I hope that maybe somebody out there might find this AdventureScript project that I've created to be interesting. If you are, then feel welcome to contribute to it. And if anybody can actually solve the Oxbow Castle game, let me know in the comments, because I'm not sure if it's really playable or not. It'd be interesting to find out. All right, thanks. Bye.